Hello guys, this is our very first session for EE212 lab, and the first lab we're going to go through is the master slave lab. So uh, let's first see what is a transparent latch and how can we write a transparent latch in VHDL. So the first thing we need to know about transparent latch is a basic storage device. Actually, it's the simplest storage device that you can find on VHDL. So every VHDL component or entity looks like this. It's a black box. For now, we don't know what's really going on inside the latch, but what we know is that we have 3 inputs and 2 outputs. So what are the inputs? The inputs are reset, data, and gate, and the outputs are out high and out low. One interesting thing about the input and the output is that little sign here, that triangle that you see. This one means that this is active low. So what does it mean? If an input is active low, it means that whenever you have a 0, this input is activated. But this one that doesn't have that triangle means whenever data is 1, it's gonna be activated and do something inside the latch. And you see this triangle exactly here as well. So let's take a look at the truth table of transparent latch and see how it works. So the way it works is whenever your reset is low, it means that the reset is asserted and it's activated. So whenever in a digital circuit you have a reset, actually everything should stop in the circuit. So what happens here whenever reset is low or activated, because this is active low and you have a low reset here, the reset is activated. So this little signs here, which are actually explained here in the footnote, says don't care. It means that whenever the reset is activated, no matter what gate value or data value is, your output high will always be low and your output low would always be high. It means that this one here would be a 0 and this one would be a 1 whenever reset is 0. So low here means a 0 and high here means a 1. And the signal here in VHDL, actually the inputs or outputs sorry, can be either 0 or 1. And this is how we show 0 with low and 1 with high. So what happens whenever reset is high? Or in other words, it's 1. Whenever reset is 1, you go and take a look at the gate signal. And if gate signal is low, no matter what your data is, your output high would actually retain its previous value and output low will do the same thing as well. So we will explain this a bit later. Don't worry about this. Let's take a look at the last two here. So whenever reset is 1 and gate is 1, you see here whatever the data is, it's going to be passed to the output high. If it's low, your output high would be low. If it's high, your output high would be high. And your output low would actually be the opposite of it. So whenever data is low, your output low would be high, and whenever the data is high, your output low would be low. So this gate here acts as a switch or an activation key here. Let's just assume that it acts like that. And whenever it's asserted to 1, it's going to pass whatever the value on data to the output high and the inverse to the output low. So this is the truth table. And whenever you have some value here in output high and low, if you disable the gate, or in other words, put 0 on it, these values actually retain their previous values, the outputs, and they don't change. So this is some kind of a storage element. It means that if you disable the gate, it's gonna just store its previous value. This is actually what we call storage. So this description of the circuit are actually written here in the text here. So let's just see how we can code this component here in VHDL before we even go to the master slave flip flop, because that would be the next stage, and we would like to just go through everything step by step. So what I need you guys to do is just open your Quartus, and the version of your Quartus that you have on your system actually could be anything. Mine that I'm using here is Quartus 19.1, so yours could be basically 18, but it doesn't matter actually. It's all the same thing. So the thing that the window that's going to pop up here is going to tell me that basically, oh, let's just use the other version. So the first thing I want you guys to do is first activate your VPN. And make sure the group is NMSU. Just press OK. And whenever you have this message here that tells you that it's connected, it should be fine. So go to Quartus and open your Quartus according to the installation guide that I uploaded on Canvas. You should have a Quartus here. And mine is 19.2 Quartus Prime Pro. I'm using this version today. So the startup window should be like this in Quartus. And we want to make a new project in Quartus and test our codes. So you can go to Files, New, and New Quartus Prime Project. Just click on OK. So this is the introduction page. You basically click on Next. And in this page here in the directory, it tells you where you want to save the files. So the best solution for you guys would be go to your documents here and just make a new folder and just name it anything you want. I already have a folder here which is called Quartus, and you can just make a new folder here and name it Lab1. Just select the folder. So it tells you basically what is the name of this project. If you go back to the lab handout, you're in the steps. It tells you create a Quartus project name Translash. So the name of the project should be Translash. You just copy it, paste it here. It will automatically be pasted here as well. After you have the right address here, just click on Next, an empty project, Next, Next, and this device here doesn't matter because we don't want to implement the designs on the FPGA. Next, next, or finish. Now you have a project here which is called Translash. Basically, we want to make a new VHD file in this project, because whenever you double click here, it says that we don't have basically anything in this project, and you need to just actually come up with the VHD files and type some code. So the next step would be going to File, New, VHD file. So here you have a VHDL file. The basic thing about VHDL file is 2 lines that you should always put in every VHDL code you're gonna write from now on in this lab. So the first line in VHDL code actually starts with library IEEE, and the next one would be use IEEE.std logic underscore 1164 dot all. So these two lines are essential, and you should always provide it in your VHDL code. So two things I want you guys to put in your code is your name. So basically, a comment in VHDL starts with double dash name would be your name, and the other thing would be date. August 26th for today. So after you put these lines in your code, let's get down to business. So the first thing you need to come up with is the entity. And the name of the entity should be the same as the name of your project here. So it should be trans/is. So actually you have to kind of memorize the syntax here in order to type your code faster. So the syntax is like entity trans/is. So what does the entity contain? Entity contains some ports. So the syntax is like this: port, and you open bracket and close it, and then you put a semicolon here, and then end entity. So the next step would be putting some ports here. If we go back to the PDF file and see what were the ports for this entity here, we had some input ports and some output ports. The input ports are reset, data, and gate. So we have reset, which is input, and we show it like in, and the type of the input is std logic. So this std logic is actually stands for standard logic, and this is the kind of input and output we always put in a VHDL design in order to actually that the inputs and the outputs of the entity could be compatible with the FPGA. This type is necessary. So whenever you have a single bit here, which could be an either 1 or 0, we put only standard logic. If it was a vector of bits, we could have put standard logic vector, which we don't need here in this lab, so we'll go through it in the next lab. So for now, what you only need to know is that we have some inputs and outputs. So the first input was reset, and the mode was in, and the type is standard logic. And after you finish the first input, just put a semicolon and go to the next input here, which was data. You can align these lines here so your code would look prettier. This one is standard logic as well. Put a semicolon. The next one is gate. Standard logic. So these were the inputs. So how about the outputs? We have out high and out low. Out underscore high. The mode is what? It's out. Type is standard logic. Out mode. Standard logic. So the thing that you need to notice is that every line here, after you finish it, you need the semicolon, except the very last line where the semicolon actually goes goes after the bracket here. So you don't need a semicolon here. Just skip it here and put it there. So after you make sure that you put every single input and output, your port declaration is done. And you just end the entity. The next step would be here declaring the architecture. And this is where your code description goes inside. So everything should be written within the architecture, the description, the behavioral description of your entity. So architecture, behavioral of translash is. So every architecture has a begin and then end architecture. So this is the syntax you should actually keep in mind. So here in the begin, we need to describe the code. If we need to describe the code, actually, we need to put the code between begin and end architecture. So I'm gonna explain the code in the next video.